Ready? Welcome to part 2 of our Algebra 1 exam review. Filming this outside today in the sun, and so maybe if you're lucky you'll see a hummingbird in the background or something like that occasionally. But why don't we get started? So we've learned in Algebra 1 3 different types of graphs. We learned lines, which is actually last semester, but it was so important that I really thought it needed to be hit again. We learned exponentials, which are curves that kind of start off flat and take off like an airplane or come in for a landing. And then most recently we've learned quadratics, which are the U's or the upside down U's that have a vertex and highest point, lowest point sort of thinking. So we'll look at each of those in a moment. First thing that we learned back actually in October or so were about lines. And so there are a couple different formats that you can write your lines in. Y equals mx plus b is the most popular by far. In that case, m is how lines move. That's the slope. You might remember the song. M is how lines move. That's slope. And b is where lines begin. That's the y-intercept. Another very popular format is point-slope form, which also includes the slope, but instead of having the y-intercept, you can have any point you want there. And then finally, standard form is not as popular, but it's a nice organized, clean format. Something x plus something y equals something. And in situations like that, a and b are kind of related to the slope. They're kind of rise and run, as long as this is a minus sign in between them. A and B and C have to be integers, nice numbers, if you're using standard form. So, what sort of questions were we asked in that sort of scenario? A question might be as simple as graphing a line. And so, to do that, how you would think about that. This is one that is given to us in y equals something x plus something form. And so the plus b here at the end, 7, that would be where I would begin the line. And so I would start by putting a dot on the y-axis at 7. And then the negative 1/3 is a slope. And so that means from that point, I would go down 1 and over 3. That's rise and run. Down 1, over 3, down 1, over 3. And so the line here would look something kind of like that. Another type of question that you might be asked is write an equation for a line. And maybe we give you a slope, or maybe we give you some points that it has to go through or something. In this case, I've given you 2 points, 3, 8, and 5, 12. And so the process that I suggested that you do to come up with an equation for something like this is to start with a template. And so the most common template is y equals something x plus something. And in this case, we're going to have to do a little bit of a side quest. I need to figure out what the slope is to put here. And so if I do that, the slope, remember, is rise over run. And the rise is how the y's change. And so that would be from 8 to 12. That's an increase of 4. A lot of times people will write 12 minus 8 to calculate that. And then the run is to go from 3 to 5, or you find that by doing y2 minus y1, 5 minus 3. And so 12 minus 8 is 4, and 5 minus 3 is 2, and so the slope in this case would be a 2. And so now that we found the slope, we can fill this blank in. This needs to be a 2. And then we'd have to figure out what the y-intercept is. And to find the y-intercept, there's a couple strategies. You could make a table, you could sketch it out on paper, or you could do the plug in a point trick, which is what I like to do. So I'm going to make a copy of this in a moment and temporarily pick one of these points to plug in for x and y and see if we can calculate what this thing has to be, which I'm going to call b for now. So if we use, say, this first point, 3 is our x-coordinate, so I'd put a 3 in here. And 8 is our y-coordinate, so I'd put an 8 in here. And we'll calculate what this equals. 8 equals 2 times 3 plus b. That would be 6 plus b. And if we subtract a 6 from both sides, that means b has to be a 2. And so in this case, both the slope and the y-intercept were 2's. So that's the idea behind lines. Again, that was a first semester topic, but I think a very important one. Lines are not going to go away. You're going to see them in Algebra 2 and in geometry and pre-calc and things like that in the future too. Definitely worth reviewing. The next type of thing we learned was an exponential. And so an exponential was the first curve that we saw. And like I suggested earlier, they kind of start off flat and look a lot like airplanes taking off. So they start to curve. That's an exponential growth. And the formula that we learned for exponential growth looked like this. Y equaled something, and then in parentheses what we called a growth factor, 1 plus r, raised to an x. And that's kind of the important feature, that x is in the exponent. And in situations like this, a is the starting amount. It's kind of like the y-intercept. And r is the percent that it changes per unit of time. So if you have exponential growth, something taking off, then you start with 1 and you add that percentage. And if you have something coming down, decreasing as time goes on, that's called decay. And the only change in the formula is you do a subtraction instead of a plus. So here is a kind of a sample question with that. This is made up numbers. I have no idea what the actual numbers are, but it seems fairly reasonable to me. It says at the beginning of the outbreak, when there was only one case, every day the cases of new cases of COVID-19 were growing at about 20% each day. And so the question is to graph the number of cases over the first month. So before we can make a graph, we need to think about a couple things. We need to think about what sort of window setting we need and also what equation we might have. So why don't we do the equation? It's going to fall in this template. In fact, let me just copy that over here. And A is the starting amount, the number of cases we had when we began. And so I'm going to say that that's the 1 that they gave us. And then R is the percent that it changed per unit of time, in this case per day. And so 20% is 20 over 100. And we typically write that as a percentage, or as a decimal. So 20 over 100 is 0.20. And you could leave it like this, or a lot of times we clean this up and write it as 1.20. So here's the equation we're going to need to graph. We also need to think a little bit about the window settings. And so window settings were an important thing that you learned this year. And so here is a kind of a pseudo graph here. I want to graph the first month. And so x is the unit of time. And I think in this case, we should go maybe starting at 0 and going the first 30 days. And so we learned that this is called x min and this is called x max. And if you want numbers along the way, like 5, 10, 15, 20, that's called x scale. Vertically, I'm not exactly sure what sort of numbers to do, but I think I should start at 0 and maybe I'll go up to 100 and see if that's good or if we have to go even bigger than that. Again, this is a y minimum and a y scale. And for these graphs, you really need some sort of a tool, like a graphing calculator or Desmos. So I'm going to hop on Desmos in a moment and make this graph. So I've already typed it in here, and this is kind of the initial settings that show up in Desmos. I'm going to adjust the settings to include the x min and max and scale that we had thought about. And so the x-axis, I said we would start at 0 days and go to 30 days. And for a step, I could go maybe by 5 days or maybe 7-day increments because that's 1 week. And I'll just say on here days since outbreak. The y-axis represents the number of cases, and I suggested starting off by going from 0 to 100 and maybe by 10 cases. And that's a pretty good graph. A couple tricks in Desmos. If you just click and drag, you can move it around. If you 2-finger scroll, you zoom both x and y axis at the same time. And if you hold shift and drag on just the x or the y axis, then you can adjust just one of them at a time, which might be useful. So anyway, maybe in hindsight, going from 0 to 600 would have been a good graph to look at. that's an exponential graph. And then most recently, we learned about quadratics. And quadratics are sometimes called parabolas. They look like this. They can either open up or down and come in a couple different formats. The most common format is standard form here. In standard form, the number in front of the x squared term is called a, and that determines whether it opens up or down. If a is positive, it's happy and it opens up, and if it's negative, it's sad and opens down. C is the y-intercept. It's kind of a nice, quick, easy point to find. And the most crucial point to find on any of these is the vertex. And when it's given to you in standard form, you'll have to remember this little formula. So you find the x-coordinate of the vertex by doing negative b over 2a, which I taught you was the first and last bit of the quadratic formula. So the song, x equals negative b all over 2a. That's the x-coordinate of the vertex. And you take that number and plug it in, and that gives you your y. So that's standard form. They also sometimes come shaped like this. Y equals something with parentheses. If it's in parentheses form, then the thing that pops at people is the x-intercepts, or sometimes called the roots. Those are the things that are inside these parentheses. And in that case, if you want to find the vertex, you're going to have to start by finding the average of these roots and then plug that x in to get a y coordinate. So we'll look at a couple of quick examples of that. So here it says to sketch a graph of the equation 3x squared plus 12x minus 4. So we could hop on Desmos and just take a look at it if we really wanted to. 3x squared plus 12x minus 4. And I'll jump back to the home screen. And so it's going to look something like this. And, you know, the vertex is down here somewhere. But we don't necessarily need Desmos to be able to find those. And so I could have told you it was going to start to open up because a was positive 3. And so it's one of these sorts of graphs. If we wanted to find the vertex, what I would do is use the formula, negative b over 2a. And so x equals negative b over 2a. And b in this case is 12. So negative 12 over a is 3. So 2 times 3 on the bottom. That would be negative 12 over 6, which is divides nicely to negative 2. So I know the x-coordinate of the vertex is negative 2, but I don't yet know how high or low that lowest point is. And so now what I need to do is to take that negative 2 and plug it in for an x and see what I get. And so why don't we do that a moment. A is 3. I'm going to put a negative 2 in here. B is 12. And again, I'm going to put a negative 2 in here. And C is minus 4. And sorry, the colors aren't going to work very nicely out. But we'll calculate what this gives us. Negative 2 times negative 2 is 4. 4 times 3 is 12. And so this part is 12. 12 times negative 2 is negative 24. And now if I calculate 12 plus negative 24 is negative 12. Minus 4 more is negative 16. And so that means the lowest our graph goes is negative 16. Should be down here somewhere. And so there's a rough sketch of what this graph looks like. And that's all I had asked for, really. So one last example, and that is how do I do a similar sort of thing when it's in factored form? So this says negative 2 times x plus 4 times x minus 10. This number in front that's not attached to an x or anything, that's an a, and in this case it's a sad polynomial because it's negative 2. So it's going to be a graph that opens down. And if we wanted to figure out some of the points it goes through, if we look at just this chunk and think about what x makes that a 0, that is one of the roots, and negative 4 would make that a 0. So that means this graph has to go through negative 4 on the x-axis. If I look at this factor, 10 would make it a 0. And so that means it has to go through 10 on the x-axis. And so I got a decent sketch here. It's going to look something kind of like that. What I need to do, or what I'd like to do, is to find the vertex. How high up does it get here? And to do that, what I would suggest we do is find the average of these two roots. So this is -4 and this is 10. What point is exactly halfway in between -4 and 10? To find average, you add the numbers up and divide by 2. So -4 plus 10 is 6, and 6 divided by 2 is 3. And so that means the x-coordinate of our vertex is at 3. And if I want to know what the y-coordinate is, I have to plug in a 3. And so let me do that a moment. So we'll put in a 3 here and a 3 here and see what this all calculates out to. That is -2 times 7 times -7. And so 7 times -7 is -49. -49 times -2 is +98. And so this would go up actually really high. So that's the idea behind some of the different graphs we've learned. As you are making your own slides this week, if you have trouble coming up with a formula that seems to be working well, feel free to ask me. Just kind of want to see that you understand the different forms and what the different numbers in them mean and how you can make a graph of them. So hope that works well for you. Sorry for the longish video today. Have a great one.